afternoon, sir.
Good afternoon.
Hi, good afternoon.
Shajil Mash, why don't we start? Let us begin.
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Yes.
Shajil Mash, why don't we begin?
Thank you very much, Shajil sir. So can I start or? Okay, perfect. Let me just share my slides and then. Oh, okay. What is happening? Just hold on.
But he is in mute mode, sir.
Yeah, I got it. It's fine. It's fine. Hopefully you can hear me as well, right? I hope the screen is visible to everyone. Perfect. Yeah. So, very good afternoon to everyone. So, thank you very much, Shajil sir, everyone who was involved, and the complete team behind this. I think it's a great initiative. And let me apologize, first of all, because Shajil sir has been in touch with me for quite a while. But somehow the second Saturday, and then, things did not work very well. I've been traveling also for some time. But I'm glad that I could make it today. So once again, thank you very much. And it's certainly so glad to see several students out there. And, I can see from, students to all the way to the veterans here sitting, attending this meeting. And then it is absolutely, a delight for me to be here today. And, what I will do today is, I have actually looked at, I think Shajil sir has shared with me some of the previous, talks, titles and all. So I could see that, more related to the space and other things. But what I'm going to do today is maybe completely a different topic, from what you have learned. And, students also might, find it something new, I believe. So this is on batteries, okay? This is on batteries. And then, at least looking at the title, probably you could make out, there is this clean energy initiative that people are talking about globally, right? So, there are several components to it. There are several parts to it. You really wanted to achieve this, zero emission or whatever you call it, clean footprint, energy, landscape that you talk about it. And there are several factors to it. And one of the things would be to look for storing energy, right? And that's something that I'm going to talk about today, bringing you to the world of batteries, rechargeable batteries. It's nothing new to all of us because one way or the other, we're quite used to using batteries, seeing batteries, and exploring this for newer and newer applications as of today. Is that right? So I come from Indian Institute of Science, Education and Research in Thiruvananthapuram. And I believe most of us, most of you know this institution. And again, these are like, so this is the campus view. I hope my slides are moving, visible to all of you. So because I can't see my snippets here.
Here's just good slide.
Okay, great. Yeah, thank you. So this is the sort of an aerial view of our campus in Vidura in Thiruvananthapuram. It's about like 35 kilometers from the city, or rather close to 40 kilometers from the city. It's a beautiful campus for those who are around, those who are coming this way. I would strongly suggest visiting us. And often we get a lot of students visiting these days, on a weekly basis. We take them, around the laboratory. They get really excited, inspired with what they see in the laboratory. And the teachers around, request is that please, take this opportunity, bring them over here. And apart from this, you can have a nice tour of Trivandrum as well. So this is what we have. And it's a beautiful campus, you can see. And then, could see it's just green everywhere, right? We talk about green all these days. All right. And for the students' point of view, I would just spend a minute or two to tell you what this institution is all about. Reasonably new class of institutes, so to speak, Indian Institute of Science Education Research, and meant for sort of taking care of both the research as well as the education, because at some point of time, it is noted that somehow these are separated, right? So research happens in these research institutions, whereas teaching or education happens mostly at the universities. And there was a need for bringing it together. And I believe that's the start of all these institutions way back in 2006. And our institute was started in 2008, and now we have 7 IISERs across the country, right? You could get more information about these systems, the way one, could approach these systems, especially the students, if you wanted to get into the systems. And let me also tell you, I can very clearly see that, the students who are attending are highly motivated, wanting to do something in science and technology. And if you're keen to take up your career in science, in basic science, I think this is probably one of the best places that you can think of in the country today, because so much rooted into exploring basic science, right? All the way, along with the wonderful teaching experience that you would get here, right? So I'm not going into details about it. We do have our, IISER aptitude test. We call it IISER entrance tests. This time it is on 9th of June. It's coming next month. So there are other ways of getting into it, even through IIT JEE main list and things like that. There are other programs to it, not just the integrated BSMS programs after your +2, but then you can also join at various stages, like after your bachelor's, like the PhD degree, you can come for an integrated PhD program. And there is also a master's program, MSc programs, and all the basic sciences like physics, chemistry, biology, and mathematics. And of course, there are regular PhDs in all streams. And we have recently started a couple of programs, one on data sciences, and one is on earth science, so to speak, right? So with that note, I would just start here. This is a bit of, things, what we do here at IISER. So, in my group, basically, we work on a variety of materials. I'm not going to the details about it. I know, lots of wide range of people are around. So I'll just, say a few things. We work a lot on materials because materials are the key, to any technology, because, there's a great saying which goes like those who control materials control technology. I think it's very relevant even today. Be it any technology that you think of, be it software, be it energy, be it, whatever it is, right? Electronics, anything, right? If you really wanted to do something, if you really wanted to, improvise something, if you want to come up with something new, basically you'll have to go down and try to manipulate at the materials level. And that's precisely what people are trying to do today, right? You wanted to bring down, you wanted to get down in terms of the IC chips and things like that. Yes, certainly you'll have to work on the materials. You wanted to come up with the new energy storage batteries or anything for that matter. Materials are the basis of it, right? So it is highly essential. It's so important that you look at materials. And that's exactly the reason why there is so much interest today in exploring, various aspects of material science. So, that's something that we try to do, but a very, very clear focus on, energy and environment. I'm not going to details, but then, that's what we do. And this is my research group, because I usually start with thanking my group because it's their hard work and, effort. And, believe me, all of them are from, very regular places. And with their hard works and effort, we keep moving, right? And as some of us know, we do need funding when you wanted to do some research like this. So we are thankful to several of the agencies, industries that, kindly contributed towards this, right? All right. What I will do is forget about all this outline, but then what I'm trying to tell you today is little bit on energy. So I think this picture is probably clear, and self sort of explanatory, right? Because carbon footprint is a concern, for everyone, right? Increasing carbon footprint is a global concern. So we got to get down with this, right? And that's where we have to go. And renewables are the only way to go. Absolutely. I think, even the students, children, you will understand that, we'll have to go back to the renewables, and there is no other way, right? For powering a safe future, right? Well, I mean, you can think of solar cells, you can think of, wind energy, but then there is a problem with these kind of energy sources because, they're not there all the time, right? For example, if you wanted to make use of them in the night, during rainy seasons, it's going to be difficult, right? These are intermittent sources of energy, and you pretty much cannot depend on this energy all the time. So what do we do? And that's where we would want to store this energy, right? In whatever form that you can think of, right? However you plan to do it, but then it's so important that the energy that we generate from these sources, the renewables like solar or the wind or anything of that matter, are to be stored, right? And that's the importance of storing these energy. It's very, very high. And now you can, whenever you think about storing electricity, right? Couple of pictures would come to your mind. Of course, when even before that, you could store energy, in different formats, different ways, like the mechanical energy, chemical energy being stored, electrochemically you can do it, electrically you can do it, right? And, right now we can see all sort of things here. And let me take this as a pointer here. Yeah, perfect. All right. So, when storing electricity, right? I think, I understand there are some students from 9th standard onwards, probably 9th or 10th, I don't really remember. You probably would have got to know something about capacitors, or maybe some of your physics laboratories, you would have seen some dielectric capacitors, right? So, when somebody asks you about storing electricity, I think the first thing that might come to your mind is probably about this forget about capacitors, dielectric capacitors, electrolytic capacitors, right? And what essentially it works, the way it works is, you have two parallel plates, right? And that's what we call it as a parallel plate capacitor as well. Parallel plates, energy is stored on the surface of these parallel plates. And then, of course, there is a dielectric medium. And, that's the way it goes, right? But then what I'm going to talk, or rather, mentioning here is something super about it, right? Because if you remember, the capacitance that we all know of, these are like very, very minimum. For example, you're talking about something like microfarad or, millifarad, -3, 10 to the power of -6 and all. But then, instead of taking a parallel plates, metallic plates, if you think about taking something like a high surface area materials, just like porous carbon, right? Even something like, what we have, burnt carbon, umikari or something, anything that you take, these are highly porous. And in these porous, you can, as you see here, you can actually store these charges, positive and negative signs. You can see charges, you see. And when they store it, eventually, because of this high area, surface area, you get to store more charge. And that's why it is called supercapacitors. And its capacitance is of the order of height, hundreds of 100 to 200 farads. On the other hand, there is something called batteries, which probably at least terminology or term by, what a battery. It's an electrochemical storage device. When I say electrochemical storage device, it is supposed to have a negative electrode, a positive electrode, as well as a separator, right? Or an electrolyte, right? The electrolyte does two jobs. The electrolyte here that you see, it does two jobs. One is it separates the two electrodes. Otherwise, the two electrodes will be, it gets shorted. So it is also, there is a separator. And also it wets these electrodes. The electrolyte contains these carriers, the charge carriers, positive and negative ions, right? There are a lot of difference between the way the charge is being stored in these two devices, right? Let's not worry too much about the capacitor, but I was trying to talk a little bit on batteries. Again, let me tell you this. The whole world of battery, the whole energy storage is a very vast area. So within this limited time of 1 hour, we might not be able to complete everything. So don't have to worry about it. Wherever we are, we'll stop, and we can discuss further. I think that would be better, right? My idea is basically to go from here and then slowly, gradually go to the cutting edge or the current state-of-the-art technology in this one, right? Students might find
Excuse
it
me,
difficult,
sir.
but then, yeah.
സാറേ ഇതിൻ്റെ അകത്ത് ലൈവ് ഷെയറിങ് നടത്തുന്നുണ്ട് യൂട്യൂബിൽ.
ചെയ്തോളൂ.
അല്ല
നടത്തുന്നുണ്ടോന്നാണ് ചോദിക്കുന്നത്.
പ്രജീഷ് പിന്നീട് സംസാരിക്കാം. ഓക്കെ, ലേറ്റർ. ഓക്കെ.
All right. So I will just move on. So probably I'm not very sure about the present, the children, kids here, but then to all of us, when it comes to battery, we will go back to something like lead acid, nickel cadmium, nickel metal hydride batteries, because these are something that we were familiar. Like 1.5 volt, we can easily go and purchase from the stores, right? But then things have changed a lot. Now we depend on lithium-based batteries. We call lithium-ion batteries or lithium metal batteries, right? Why is that so much dominance for the lithium these days? Because whenever you get to see batteries now, the first and foremost thing that gets to your mind is lithium. The reason is very simple. Lithium is the light element, and lighter weight, of course, it gives you an advantage when it comes to storing energy. When it talks about energy density, it shows very high energy density. Number one. Second thing is, if you know about it, all the other batteries like nickel metal hydride, nickel cadmium, and all these are constrained in terms of the voltage that it has, about 1.5 volt. On the other hand, lithium, because of its electrochemical properties, it has a voltage. Lithium-ion battery is a voltage around 3.5, 3.6 volt, almost double, more than double, right? And that would reflect in the energy density, because some of you know that energy density is calculated. Energy is something like half CV squared, right? Or V into I. So there is a factor of the voltage there. So as the voltage is good, of course, your energy is good, and energy is something that we badly need it, right? Because, I'll tell you exactly. So the whole development of lithium-ion batteries, it started sometime in, mid-70s, I would say. And then it got commercialized. The battery, the first lithium-ion battery was commercialized by Sony in the year 1991. So it's almost like 30 years of research has gone in, and we were all glad that the real people behind these development, they've been honored with the Nobel in 2019 in chemistry. And I also wanted to bring a particular point here. I keep telling my students as well all the time whenever I get a chance, because at least the upcoming students should know this, because most of us, when we were brought up in the colleges, on the schools, these disciplines were sort of compartmentalized, because we got to say physics, chemistry, mathematics, biology, and forget about it, engineering was completely away for us, right? So, but then things have changed a lot over the years, and if you look at it, the world is sort of moving towards interdisciplinary research, interdisciplinary approach, because no more it is restricted within the walls of physics, chemistry, or biology, or mathematics. But then we need people to come together, because we are especially when you wanted to tackle big issues, when you wanted to work on really societal importance, high importance, or big projects, we want people to come together. Physics, chemistry, material science, mathematics, engineering, data science, everybody need to come together. And this is a classic example of that. And that's what I'm coming to. For example, John B. Goodenough, he just passed away last year. He was like 102 or something. So, he was actually got his PhD in theoretical physics, right? And, he moved on to do, experimental physics, and later became the head of the Department of Chemistry at Oxford in UK. And he started, whereas Stanley Whittingham is a chemist. And the Akira Yoshino, he was an engineer from Japan. And these three people actually worked independently at different times. For example, one started in 70s, one started in 80s, and the other started in late 80s. And that they put together nicely the current lithium-ion battery that we all know of. So just highlighting the importance that we all have to come together, irrespective of the discipline that we are trained for, right? Especially when you want to really get into this business. Okay, just a quick, outline about the working principle of batteries, especially the lithium-ion batteries. For example, if you were to cut open a battery, don't do that ever. But if you were to cut open a battery, the cross section would look something like this. You have an anode compartment, you have a cathode compartment, and of course a separator, an electrically insulating separator here. And what do you see? In the anode and cathode compartment, there are respective particles, materials, particles, these nice spheres that, the green and the other color that you see, these are like particles, typically different particles. And you can see that they're glued together with a blue material, because otherwise they tend to go separate. So there is something called the binders, we call it, maybe a polymer or something which glues together. And also you can see that there are some black lines which goes nicely, which connects. These are called electronically conducting binders. Otherwise what happens is these are like entities, they get separated out. So you need to have a communication talking between these two electronically, because that's why these are joined together. So we add some carbon, right? We add some carbon that binds these things. Anyway, this is something. And what it really happens is you have a graphite, you have a, in your current battery system, you have something called graphite, which all of us know. These are layered, hexagonal sheets of carbon. And these are still being used as anodes in the battery. And just think about it. The Nobel Prize, which I showed you, right? And this was given to this system. The people whom I have shown, they only discovered these graphite as the anode and this material, something called an oxide, like lithium cobalt oxide as the cathode. They only discovered it around 35 years back. And can you believe it? We are still going on with these materials as the component of the battery. So altogether, I think I would say that the battery technology has been quite laid back, right? When you talk about the progress, that's the way it is. Anyway, so what happens in the battery is you have these lithium ions, which is there in this lithium cobalt oxide. This is a material, don't worry much about it. But then there are these lithium ions nicely sitting in between these two shells. And when you charge the battery, typically when you plug into a battery, what happens is these lithium ions, think about this is a reservoir for a lithium ion. So nicely like the shelves that you have at your home, right? These lithium ions can go into the shelves, right? So whenever is required, when you charge it, these lithium ion, the green balls will go through this conducting medium and get seated to another shelf which is there. Again, these are like shelf-like thing because graphene, these are like graphite hexagonal layers. These lithium can again get intercalated, we call it. Intercalated means between the layers, it can just get pushed in. So it gets nicely, goes to the next set of Almara layers, right? And once the entire lithium ion gets to this, we say that, okay, my battery is charged. And then we start using the battery, for example, to light up something for calling your mobile phones, right? Then what happens? then there are some chemical reactions happening. We call it oxidation and reduction reaction. All of us know about it. Combinedly redox reaction, we call it, right? Oxidation reaction happens at this anode, which means like there will be a release of electrons and the lithium ion from it. And these lithium ion will go back following this path and get placed in the original shelf it was. In the meantime, these electrons cannot go through it because it is an insulating medium here in between. So it has to take an external path. And that's where you get the power for powering your mobile phone or your light. And these electrons will come over, meet with the lithium ion, get reduced here, process is complete. That's a simple working mechanism of a lithium-ion battery. Now, there are different ways, ways of packaging these lithium-ion batteries. Most of us are familiar with this also because that's what your mobile phone battery says, right? And carefully look at it, it would be written like lithium-ion battery. There will be something like, 2 ampere hour and all is written. So anyway, these are different types of lithium batteries that you can think. Of course, people try to, do it in different ways, in cylindrical way, in prismatic way, all sort of things. Let's not worry about too much about it, right? All right. Okay, good. So have you ever thought about how do we get this voltage? I think at least to the kids, I'm saying, the children, when you go back, if somebody asks you, what is the typical voltage, or the potential that you get in a battery, you should be able to tell. It's about 3.6 volt that you get in a lithium-ion battery. And what is the origin of that voltage? Where does this potential comes? That is, if you understand it, take it. Otherwise, don't worry. So what happens is, I told you there are 2 reactions happening, one at the anode, one at the cathode. And when it happens at the anode, there is a reaction happening, represented by this pink line. And this happens at a particular voltage. You can see on the y-axis, a particular voltage is there. Let's say 0.4 volt, 0.3 volt. At the same time, there is a reaction happening at the other shelf. I told you about the other shelf, the lithium cobalt oxide shelf, where reduction is happening. And that happens at a particular voltage around 3.9 to 3.8 volt, right? And anytime the difference between these 2 reactions gives you the cell potential. And you can very well correlate that around 3.94 volt minus around 0.3, 0.4 volt will give you around like 3.6 to 3.5 volt, right? You can notice that I have noted there are several yellow lines written here, right? These are danger things, yellow, caution, right? These are issues that are bound to happen in a battery. Okay, there are several issues, and that's the result. I will talk about it a little later. You probably would have heard about batteries exploding, especially when it comes to these kind of batteries which are placed in the in the automobiles, the electrically driven vehicles and all, right? We'll look at it later. I just wanted to see this. If you do not understand this flow, please do not worry about it. But this is the origin, and at least take home the batteries gives us a voltage of around 3.6 volt, the existing lithium-ion batteries, right? So as a material scientist, again, we have quite a lot of room to play around, because in each of these compartments that I talk about it, anode, cathode, or the electrolyte, we have lot of materials that you can pick and choose. And that's precisely what a material scientist does, right? Try to plug in one material from here, another here, see whether that combo or the combination works. And this is something like you walk into a kitchen and then start playing around, rather start picking some, curry powders, right? Everything has to go well matching, otherwise you don't get the taste. So, so that's exactly the case here as well. Maybe an anode material is too good, but then unless it cooperates or it matches well with the other segment, it's of no use. So a sort of, what do you call it, a real optimized things are important to come up with the high performance batteries. Few things important to worry about it for a battery. Safety, of course, important. cost is something to be worried about, and more importantly, the battery life. I think you also, forget about whether you know about batteries or not. When you buy a battery, I'm sure these are the three things that you might want it to be worried about, right? Because I want my battery to be safe, no explosion. Of course, it has to be very, very cost effective. And if I buy a battery, to me, it should exist forever without recharging it, right? So I think this is exactly what people like me, as a materials person, trying to do in battery technology, right? Playing around with materials, really manipulating the various properties of this material so that, you get to improve or enhance all these three parameters and then, give it out, right? Now, you might have heard about nanomaterials. I'm sure some of the students now, for students also, these are being taught in the class, right? Nanomaterials, very tiny particles. It comes with a lot of interesting properties. I'm not going to talk much about it, but just a word about nanomaterials in batteries, right? For example, if I take a bulk material, this is the way it goes, right? Instead of bulk, if I were to take a nanomaterial is you crush it, you take a hammer or something, crush it into smaller and smaller particles. You can very well see that end of the day, we will be happy if lithium ion from one shelf, the green shelf, it can go nicely without any disturbance, without much problem, nicely can diffuse through the material and get to reach the other end, the pink side, right? And that's where a cycle completes, a full charging or the discharging completes. So from the bulk here to the powdered or the nanoparticles, I'm sure you'll agree with me that this particles is much better, because why? These lithium ions would find easier path, isn't it? Because the diffusion or the movement of lithium ions would be much easier here than here, right? So that's the effect of nanoparticles. Instead, if there is something called a nanowire or a nanorod, can you even think about little further? It would be something like a national highway for lithium ion. No disturbance, absolutely straight line you can go, and easily it can hit the other end, right? So, just to give you, and when I say all these things, national highway, easily hit and all, what is it translating to? The faster the lithium ion can move from one shell to the other, well, it talks about your power capability, how fast one could, charge it or discharge it, right? You want that very quickly, isn't it? Because you cannot wait for 12 hours to get your full charge of your battery. And that's where you get to see that there is supercharger these days. 1 hour it could charge it, 30 minutes you can charge it. Everybody is now trying to, see that my battery gets charged at the smallest time possible, shortest time possible, right? So just to give you an example, these are something that as a researcher, we try to explore in this area. Oh, no. You would have noticed this, right? This is something warning signal that you get to see, isn't it? Right? Even my kids, they when the mobile phone, they nicely come and give the mobile phones to hand over to me or my wife. We'll be so happy. And then when we look at the mobile phone, this is the sign that you get to see, right? Asking us, you better charge it, right? So, which we don't want, especially, right? We don't want to see the sign at all. But what about this? What about this? What is this? What does it indicate? This is actually a speedometer in a typically car. And imagine this is an electrically driven car, which means it's an electric vehicle. So think about it. You're driving an electric car in the middle of nowhere, right? Maybe in a desert or something. There are no charging stations around. So, and all of a sudden, your car started showing this beep, red alert, right? As if telling the driver, your owner saying that, hello boy, hello man, come on, please get me hooked into some plug. Otherwise, I'm going to run out of my charge. It's a very, very dangerous situation, right? It's a very, very dangerous situation. And there is something called range anxiety these days. People talk about it. This is a really worrying this thing among the owners of electric vehicles. People say that, right? You can Google for more information, but this is something really, really, dangerous, isn't it? Of concern, I would say, right? So then, if that is the case, I also mentioned about these batteries, then, you can easily think, right? Batteries are used for various applications, not just for your mobile phones, right? The mobile phones or the so-called portable electronics is just one among the different applications that we talk about it, right? There are so many applications. I would also want to just highlight few of things. The blue one, the marked one here is, in an experiment, right? Experiment, which means like batteries needed for small scale applications, miniaturized power sources. What do I mean by miniaturized power sources? Very, very tiny devices, right? So the question is like, can batteries power small devices? When I say small devices, it is so small that these are not seen even through your eyes, right? There are electronic devices, micron scale, even nano scale devices, which you cannot see through your eyes. And these are embedded in various devices. And where do they get power, right? I'm sure you would have heard about some very popular lectures or read about some popular articles on nanotechnology, right? Wherein some of you would have read about drug delivery systems, drug delivery vehicles, where people talk about very tiny nano device which can actually go through your blood veins and, deliver the drugs to the target. To, for example, the cancer cells. Yes, I can think of, getting a very tiny device which you can't again see through, load the drug in that, take it through your blood vessels and hit them. Right? So much of stories that you've heard. But then the point is, see, this is something like this. You see, a capsule kind of thing, which carries your, popular way of taking things. But then think about it, unless these vehicles are self-powered, what do we do? Can you attach a battery to it? Absolutely no, right? Absolutely no, because see, the electronics industry or the electronics technology has really outpaced. Because these days, the electronic, technology can come up with very, very tiny devices, even micro scale, nano scale circuits and all. But unfortunately, the battery technology still date back, as I said earlier. You do not have a very, very tiny battery. You don't have a smaller devices on board today, right? Same is the case, for example, what you see on the left-hand side is about the pacemaker, right? The pacemaker. And believe me, 3/4 the volume of the pacemaker is eaten up by a lithium primary battery. So can we not reduce the size of the battery so that it becomes more efficient, it becomes more even smaller and smaller in size, right? So these are very, very important. Sometimes you might say that, why don't I use a thin film battery? Unfortunately, the thin film batteries are not effective because it cannot meet the energy, density that we require, right? And that's what people talk about. Very, very nice way of taking batteries. Okay, I'm not going into detail, but just wanted to highlight the importance of developing these very small batteries, which can actually go on board these tiny electronic devices. Okay, and this is a very, very hot topic in this battery technology. At the same time, extremely challenging to work on. Okay, even in our group, we've been working on this for the last several years. But the idea is basically to tell you that, think about it. I have a battery, like a lithium-ion battery, right? You know the typical size of a battery. This is something like this. Now, I'm telling you that is it possible that I can make a battery similar like this with an anode, cathode, and a separator or electrolyte, but then my battery size should be of the order of the diameter or something should be of the order of 100 to 200 nanometer. And what do I mean by a nanometer? I hope the students out there, you know exactly what I mean by a nanometer. It is 10 to the power of minus 9 meter. And how big or how small it is, can you visually imagine what is the number that I talk about it? I'm talking about something like this. Just to give you an example, you take one strand of your hair, okay, a single hair, take it lengthwise, and you take a knife and cut that one single hair into 2 equal halves, right? Longitudinally, lengthwise. You get 1 half here. And you take 1 half and keep cutting this again lengthwise like this. Not this cutting is easy, lengthwise. Cut it into 2 parts, take the other one, cut. Continue cutting this something around, let's say, 50,000 times, right? You will get something, a hair. And the size of that hair is what I call it 1 nanometer, 10 to the power of minus 9 meter. So what the battery that I dream of building is of the order of that, 100 times of that, 100 times of that tiny battery. You cannot see through here, right? Why do we need this? Because if I get this, then I can easily place it on very, very tiny circuit. We call it power on chip. On the chip itself, we can place this. You don't have to attach a big battery, right? Because otherwise, that's a big bottleneck for all the battery, the electronic devices. I'll move on. And the other thing that you might know about is batteries are being used for today for electric vehicles. Okay, you move around on the roads, you get to see lots of these electrically powered vehicles, EV, isn't it? Right? And this is actually a mission, right? E-mobility is a huge program by our country, the government of India, as well as globally, because it does 2 things. One is, of course, it takes care of this consumption of fossil fuels. It has gone down, you can see that, right? Not only that, it also takes care of the carbon dioxide emission, right? You remember my first slide on carbon dioxide emission? These are 2 important things because we are talking about clean energy future. And in clean energy future, it is so important that we worry about greener energy storage systems at the same time, the ones which do not pollute our environment in terms of carbon dioxide emissions and things like that, right? So it is certainly going to be a reality, and there is lots of programs going on like 2030, EV 2030 program, wherein the central government feels that by year 2030, 30% of the vehicles should be electric, right? Little bit very what do you call it? It's I don't know how far it is to implement because you have to worry about a lot of things because the infrastructure needs to be developed because you have to have charging station. Otherwise, you will hit the same thing. What I told you, have a nice electric car, fantastic. I'm happy about it. I bought a new BMW electric vehicle, but then imagine if I have to drive from here to Kannur, right? And there are no charging stations in between. I'm done, right? Otherwise, you should build better batteries that can actually power, larger distance, that can continue. Its mileage is like 100, 1,000 miles or something. Then nothing to worry. And it's also important. So these 2 parameters, I would just quote one simple example so that the students will understand it a bit more. When you talk about battery, think about this. For example, you would have heard about this nice story about a rabbit and a tortoise, right? Ame moilum, isn't it? Because, one is very good in 100-meter dash sprint, right? It can go and hit 100 meters. But the other guy is very slow. What is the difference between the 2? One is the power is very good for one, right? Whereas the other person, the power is very low. It cannot do a very quick thing. But then energy density is very high. It can go mileage wise, it is good. But for an electric vehicle, you need both, right? Because you wanted to accelerate it sometime. You wanted to very quickly go from 0 to 100 kilometers per hour in 1 second, 2 seconds. That's what we call the power capability, power density. Now I say I wanted to, make sure that my car goes till Kannur or Calicut or Kasargod without recharging it, which is what, 500 kilometers, 700 kilometers. That's what we call the mileage. And this mileage is, translated to energy density. The more energy it has, the more kilometers, it can run. But then it's important to make sure that the current batteries, possess both power as well as the energy, right? Otherwise, it becomes difficult because, we're talking about using this for applications which we have never been to, right? These days, we talk about electric vehicles, and beyond that, we wanted to make sure, or we want to develop, even larger energy storage sectors, so-called grids, large-scale grids, right? Stacking batteries and keeping, which can actually power the entire village, right? These are the larger scale grids that we talk about it. Because I told you, solar power, wind power, we cannot use it immediately. So we want to store those renewables into larger grids. And these larger grids are made up of, or rather should be made up of lithium and batteries, right? And then it should have all these properties. It should be able to store, larger energy charges, right? Now, if you think about electric cars, right? Starting with the gasoline vehicle, you know what it is. You have to have a fuel here, petrol or diesel. Now later it changed to hybrid vehicles. I don't know how many of you know about something like Toyota Prius. It has both, engine as well. Fuel as well as the electricity. And there is something called the plug-in hybrid vehicles where, you have to use the electricity and things like that. And the latest one is the electrical vehicle, completely electric, because you have all these nice batteries arranged inside a vehicle, right? And of course, Tesla, I don't know whether you've heard about it, otherwise Google it. Tesla is the biggest, car manufacturers in the world, and of course, you can see Tesla is coming to, India as well, to, these people are really making lots of these kind of batteries for car, and even at the power wall, they call it, even to power your house, all these kind of things they're making. Okay. In the last part, I believe, maybe 10, 15 minutes or so, I think I gave you a brief outline about the state of the art, right? When I say state of the art, means like, what is this battery all about and what are we using currently? But that's not all about it, because, you have to worry about future, right? Right? Because it's very, very simple and easy to say this, because you really have to, think about building better batteries. Why would I need better batteries? Because what you get to see here is like a plot of energy versus power. I told you about the importance of energy and power by comparing this nice story about this, rabbit and tortoise, right? Both sprint or power and energy is required. Unfortunately, if you look at it, batteries are good in energy, but power is low. So you really need a super battery, right? Considering all these advanced applications that we are into, like the electric vehicles, which demand lot more of this, energy and power, we really have to come up with new developments in research and development, or new initiatives in research and development of battery, right? I will quickly tell you some examples that we currently explored in various research laboratories across the world. And one is innovation in lithium and battery technology. I'm slowly going a little bit on a higher level. And children out there, if you're not able to understand, do not worry about it. You can always ask me at the end. But to others, what we're trying to do is like, there is huge scarcity in terms of the lithium availability, resource availability of lithium across the world, right? It's sort of, geopolitical in nature, the distribution of lithium reserves. You can see that. Lots of issues. And, we are afraid that these also, might go to any various other issues. Anyway, having said that, we'll have to explore either new ways of lithium-ion battery, Otherwise, we'll have to explore new battery technology because, knowing the fact that lithium availability is limited, can we not explore alternatives to lithium? For example, sodium ion battery, right? The reason is sodium is abundant in nature, especially the India standpoint of view. India has large resource for sodium. So now there is major attraction or research direction towards building alternatives to lithium like sodium ion batteries. My group also, many of my students work on developing sodium ion batteries, right? And there is something called hybridization. Hybrid, capacitors and batteries can be put together into a sort of hybrid device. Let's not worry too much about it. All right. Now, we worry about the battery safety. This is what I skipped in the earlier slide, right? You get to see these batteries getting exploded, right? Combustion. There are several reasons to it, right? Especially, you get to see that when you're traveling the airplanes and all, flights these days, they have restrictions in carrying these power banks and all, into the flights, and so much of things has gone in, right? People really blame the batteries. Not always the case. I'll come to it in a minute or so, right? So, what really happens, this is an electric vehicle, a car. You see where the batteries are kept? The batteries are nicely arranged beneath the seat, right? Okay. And this is heavy. It's very heavy, right? You wanted to minimize the weight of the battery because lesser the weight of the car, the more the efficiency, isn't it? So you wanted to minimize the weight of the batteries as well. So take my word for that. The technology today is leading to something called, or rather developing lightweight batteries. And I can tell you that lightweight batteries are going to be the future technology in battery technology, thing, right? We have to develop lightweight batteries, especially with this interest that you get to see in terms of electric vehicles, right? What is the alternative to do that? I'm moving towards the futuristic, directions, right? Instead of putting all these batteries beneath the seats, can you be little more innovative? Can you be little more creative and try to place these batteries, right? Let's say on the wall on the structure of the car, for instance, what you get to see here, right? Can I actually think about making structural batteries? What do I mean by structural batteries? For example, these batteries would be embedded on the door parts, on the ceiling, right? Which means it should basically get integrated very smoothly into the parts of the car. For example, if I'm using, let's say, carbon fiber to build the parts of the car or the airplane, right? Can I use carbon fiber as an anode material for a battery so that it's very well gel with it? And this is something very hot. People are trying to think about it, something called structural battery. And this way, you could actually reduce the weight of the car, right? People started trying to do this. You see, Tesla, for example, trying to, arrange these batteries onto the side, on the car parts, on the doors and things like that, right? Long way to go. Other way thing is can you actually think about a flexible energy storage device? What do I mean by a flexible energy storage device? You take for example, this mobile phone, right? Why am I have to carry this mobile phones like this? It is like a, very rigid, a rectangular piece that it might not go into my pocket. Can I not think about a completely moldable, a foldable, a mobile phone, which would be so easy to carry with me into my pocket, into my bag, right? Some of the students, you might tend to fold your notebook nicely and then put it in your pant pocket and go take it out inside the class, unfold it. Who is blocking you? Who is the constraint? Who is the culprit here? Well, the answer is simple. It is the battery technology, right? Think about what are the essential parts. There is screen here, and people have shown it. It's absolutely possible to make flexible displays. Samsung has shown it. And the complete electronics in this mobile phone, it is all can be converted into flexible electronics. Absolutely no problem. Electronics technology has really gone far. But unfortunately, the single guy, the battery who is sitting here, the prismatic battery who is sitting inside this is not flexible, right? So you see the importance of flexibility, right? So this is something quite exciting. And I'm going a step further and say that, what if I have a flexible battery, which actually could be nicely embedded, in between the car parts, so that very beautifully the battery can be actually covered throughout the parts of the car, right? And that's something that we, as a researcher, have carried out this work some time back when I was in the United States. And, we came up with very interesting flexible battery using a material called carbon nanotubes. You could actually make these batteries. And, there was a company started way back in 2018 in New York, which is called a paper battery company. The idea is basically to make these, batteries flexible. I just want to highlight this. It's so interesting. You think about it, right? Earlier days when we came up and all, people get to see that, you got to do something. And the research that you get to do today, this is useful for the next generation. For example, your kids will get to see this. And the things have changed. Think about it. This is something which came out from my work, in fact. And, it would be so exciting for you to go to the market today at some point of time and buy a flexible battery, for instance. And, and you can see the shopwala will be, trying to put a lot of funds on these batteries. And on the other hand, think about it. You are the guy, you are the person who have invented this battery, right? And you get to buy that battery from the shop. And that's the level to which it has gone these days. And it is also exciting to note that the kind of work, especially that we try to do in this area, is so much close to the society today, right? Of utmost importance to the society that, we give back to the society, whatever little things that we get to do. I just want to highlight this so that, at least the kids get motivated out of it, right? Get into science. We need more scientists today, especially the problems are, of huge, magnitude today, not just the energy, but then water, food, everything we need to tackle today. And we need more scientists to tackle these issues, right? So I think I would just wind up in another minute or two. I think I've taken more time. Last part, I've talked enough about the safety issues, the constraint in achieving the mileage, right? Is there a possibility that I can really think of some solution to it? If I wanted to think of a solution, I should know what is the cause of this problem, lighting up, right? What are the issues? The problem is very simple because we use in all of the battery today, we use something called a liquid electrolyte. And this liquid electrolyte is a killer because one is when you use a liquid electrolyte, you cannot go beyond a particular voltage because that liquid electrolyte will decompose, right? Second thing is it will create something called needle-like structures like this from the lithium, and that will pierce through the electrolyte and touch the other guy, and then battery gets short. And apart from all these things, I should blame the automobile manufacturers also. Do not quote me, but these are also killers because, for example, these scooters, they do not pack it properly. The mechanical misuse is also a problem for this explosion. Anyway, coming to the point, what is going to happen is, what if I completely take away this liquid electrolyte component from a battery? Think about it, I have no liquid in me. The liquid electrolyte, I completely transform to something like a solid electrolyte, like another material. Then I don't have to worry about any of these factors. There's nothing to worry about fire. There is nothing to worry about the voltage. I can actually extend my voltage. And remember, voltage extension is translation to energy density, which is like what we call it as a completely solid state battery. Okay? And that's what the future is all about in terms of battery technology. I started talking about from the very initial days, and now we are going through this. Solid state battery has not really got into the market, but then take my word for that. This is going to be the future of energy technology. This is going to be the future of battery technology. It's all solid state. Lots of advantages high energy density, absolutely safe, lower cost and things like that. But there are a lot of issues. Otherwise, things would have been so easy. Almost all the automobile manufacturers, including BMW, Toyota, everyone has invested billions of dollars into it, trying to develop these batteries, right? Lots of challenges. For example, just to tell you, now you're talking about combining an electrode in between, there is another solid. So the lithium ion will have to move from this one solid, jump across it, and get to the other one. It will always find some gap here, right? It cannot just, tunnel through it. And you have to worry about the interfacing, things like that. And that's something that, we all of us try to do in our laboratories. We try to, come up with new materials which can, nicely transport these ions, worry about, or rather mitigate all these issues, but various ways. I'm not going into details about it, but to those who are interested, I'm just saying you something like that. We play around with materials, trying to make this, various polymer embedded and sort of being solid state batteries. And I think I would stop here. The last slide is, so I told you there is accelerated, development of solid state battery technology is highly essential globally. And there's been a lot of funding, a lot of investment has gone into it. And India as well invested, or rather recently invested a lot in this business. And thankful to the Department of Science and Technology, Government of India, Minister of Science and Technology. And they have initiated a big program. And this is the first of its kind in the country, that a consortium has been initiated, right, formed, to develop this solid state battery, an accelerated development. When I say accelerated development, we do not have time. We cannot wait 10 years, 15 years to develop this technology. And for that, what do? You see the list of institutions which are involved in it. 15 institutions, right? Almost like 15 institutions are involved in it. And these are people coming from different backgrounds. There are physicists, chemists, computational physicists, material scientists, engineers. They all come together. They do, AI, ML, everything, and tell us, like, screen out these materials, take these materials, then we get into it, right? And this is a huge center, huge initiative. I'm so proud to say that this center is situated in our campus. This is called the DST IISER Thiruvananthapuram Center for, solid state battery development. And I'm leading the center, in the country today. So I'm so glad and proud that, this initiative has happened, and we're working together towards actually developing this whole thing, right? So with that note, I would end here. I know it is a very wide audience today, all the way from the, school kids to the real experts in the field. But I would be very happy to take some questions and initiate some discussions on it, right? So thank you very much once again for the opportunity, and I really would love to get involved in some questions.
Okay. Thank you, sir, for your very interesting journey of research in the field of flexible batteries, and we expect much more developed batteries in future. That would happen from IISER Thiruvananthapuram campus. That we are waiting for that, and thank you for your wonderful talk. And before we go into questions, a lot of questions already posted in the comment box. Before we go into
I have not seen it.
Okay, so we will take it and consider it. And before we going to the question session, I invite E.K. Kutty sir, the founder of UL Space Club, to make a comment on this. Welcome, sir.
Sure.
Kutty sir. Hello.
I'm sorry.
Okay, sir.
This is we were fortunate to get, we are blessed to get the leader in the area of battery, Dr. Shaijumon today, and 1 hour plus he has handled the subject in an excellent manner, starting with the state of the art and going into the future, advances made, and also introduced the students to the IISER its environment, the team he is leading. All that has given a fantastic feeling to the students on a subject which the society has an increasing interest. Battery. Everywhere battery is there. See, when I was a child like you who are listening in this, there were hardly any gadgets we used where battery is involved in day-to-day life. But today, see the life, see the society. So we are very fortunate to listen on a topic of this interest to society and the interest to students engaged in chemistry, materials, electronics, and multidisciplinary tasks of a kind of battery. And it's a wonderful afternoon, and thank you very much. I don't want to come in between the speaker, Dr. Shaijumon, and the students who are curious to know many more things about the battery. Thank you very much, Dr. Shaijumon. Thank you very much.
Then,
Thank you, sir. Pleasure.
yes,
Thank you so
some
much.
questions already posted here. Then one question is from Devananda Srijit. How do humidity, pressure, climate, and temperature impact battery performance, safety, or lifespan? That's his question.
Yeah. So yeah, I can see some of the questions. So yeah, Devananda, very nice question. Certainly it has effect. Certainly it has effect because first of all, you're playing around with lithium, which is which doesn't like moisture or air, right? So handling this is important. So we handle everything inside a glove box, so we cannot expose anything. So, and also it is important that packaging should be very good. Otherwise, it certainly affects because of humidity or anything. But normally batteries, you don't worry about the humidity and all because it's nicely packed. Temperature is certainly a killer because you cannot go beyond a particular temperature. But then that's another important thing I forgot to mention: future batteries, because now people are trying to develop high temperature batteries, right? High temperature batteries which can actually even handle 200 degrees C. Right, this is important, right? Especially when you wanted to, bring for the mining and coal mines and mining and things like that. When you go beneath, all sort of pressure, temperature, everything gets into picture, and that's where all these are important. So materials-wise, it is still a challenge to develop such high temperature batteries. But then, to answer your question, some of these things are certainly crucial, and it affects the lifespan and the safety as well, right? So pressure. Absolutely, pressure and temperature is a bit of a problem. Should we go to the second question, or we are randomly picking up? What is electronic?
Okay, then one more question is that nowadays electronic vehicles are being used. In many of them, there is an option for fast charging. So the fast charging is done a couple of times. It must be charged for a long time. Only then can fast charging done one again. Why so? Okay. Explain working of fast charging.
Yeah. So fast charging again. People are doing it again. See, I can tell you something because it's always, when you think about it, slow charging is always good because you really get to take the entire reaction and take the battery through the entire reaction, so to speak, right? You want everything to go slowly and get through the entire process, right? Fast charging means, of course, you're skipping certain things and things like that. So, but then otherwise, the materials that we develop should be able to tackle this, high current. When you say fast charging means okay, I tell you something. When you buy a battery, it is written like 2 ampere hour or 20 ampere hour, right? It is written. What does that mean? It means that when you charge or discharge a battery, let's say when you discharge a battery at the rate of, let's say, 20 ampere in 1 hour, right? If I discharge it at the rate of 20 ampere, it can go for 1 hour. Same is the other way, right? So always I think slow charging is certainly good, but then, we have to get to go with the fast charging. It has its own disadvantages as well, might slowly affect its long cycling stability, right? But then, in terms of that, of course, people are trying to develop these electronics as well as the materials which can, handle this, charging, right? So next question, if I can read it, what are the changes that can be made in batteries to increase their lifespan? Good question, because that is something of concern to all of us. Well, you have to understand what was the killer here? What is the cause for the reduced lifespan here? That is important to know. So, there are several factors that plays around. One is the most important thing lifespan it affects is, when you take some materials and when lithium, when lithium enters, something like this, a material and lithium enters and come out of it 100 times. Basically, when you say 100 cycles, it's 100 times it's going in, coming out. It's like a shelf, of course. Now, at some point, there is something called some volume expansion happens because this, this material sometimes breaks down. And when the material breaks down, what will happen? This is one particle. And if it breaks down into fragments into 10 particles, the electronic conductivity between these 10 particles are lost, right? And then what happens is these 10 particles will no longer be available for charge storage because it has no communication with the outside, the circuit. And that's one reason why you can see that the cyclic stability or the lifespan is going down. So it's important that people now try to do in the modern, research and all. What we try to do is we take these particles nicely, embed them into some conducting matrices like graphene, carbon nanotubes, and all nicely. It's like you take a bed sheet and put all these particles around. And then even if the particle breaks down, it is still within the enclosure of this, bed sheet. Bed sheet, when I say it's a carbon network, which is electrically conducting, right? So these are something that people try to do in various cases to understand all this, get rid of these things, right? Well, nuclear power based is, you can see there are some recent reports, people talk about it. There are some recent studies on it, using some materials which they're trying to do it, but we do not have much idea about it, but it would be certainly exciting to look at that. Explaining a gel battery, is lithium-ion battery and gel battery the same thing? So gel battery, what it calls is I talked about liquid battery, and there is something called solid state battery. So the gel battery would come something in between. So imagine if I take a polymer, right? I have an anode, I have a cathode, and in between, if I take a polymer and I drop a little electrolyte into it, what happens? This polymer would form a gel because it consumes or it absorbs all the electrolyte, it forms a gel. So that stage is something like in between the solid and the liquid. It is slightly better than the liquid, but then it does not really serve the purpose of the safety and things like that, right? There has been, in the olden days, there's been a lot of, gel battery, but that has gone off now. But these are essentially the mechanism, everything remains the same. So since EV cars are fully dependent on batteries, they should have a good quality battery. But then why are the cars using lithium-ion batteries if they explode due to sensitive heat, excessive heat probably? Yeah, I think I mentioned that because there are multiple reasons. There is something called, these days batteries are all liquid batteries. So, there is something called a dendrite formation because what happens is lithium is going here and coming to here. And when the lithium deposits it, try to deposit not uniformly, some chunks it forms like a needle, and that needle can pierce through it and then, shorten the battery. And in order to avoid that, I think the solid state battery would be certainly interesting to look at it, right? And of course, there are other sides because many of these two-wheelers that you get to see might not completely because of the battery problem, but then it could be because of the mishandling of the battery. They don't really pack it. They don't even keep a thermal insulator or something like that, because they're selling it at a much lower price. They want to reduce the price. They avoid all these safety aspects. And then when you hit with an accident, then, there is a mechanical misuse and then that leads to this explosion as well. Decreasing the weight of the battery is very important. That's what I talked about, the lightweight batteries. But then all the way from the materials to all sort of things one has to do. Somebody asked about the wireless battery. People are also thinking about the wireless battery by, this electromagnetic way of doing it, but, it has still not gotten that one, right? Yeah, is there anything that I missed, something important that you wanted to pick it up?
Okay, then two students raise their hands. Let them ask directly.
Oh, please,
Okay.
maybe, yes. Please. I think
Vivek
that will be good.
Meenakshi.
Yeah,
Okay,
please.
you can ask directly. Okay. Archit. Okay, Archit, you can ask. Archit,
Okay.
introduce yourself
So,
and speak. First, you introduce and speak.
okay. Okay. My name is Archit. I'm from Calicut, studying in Ayathan School. I'm studying in 9th standard. So I want to ask a question. So lithium-ion batteries and other type of batteries can be recycled. So it will be effective for the environment. So what are the common methods of recycling the batteries?
Very good, Archit. That's a point which I missed it. Okay. Thank you so much for pointing it out. So when you talk about lithium-ion batteries, I think recycling is probably the very important factor that has come up recently, because I told you about the resource availability issues with the lithium, and then people are really investing a lot on recycling batteries. Even my group, we work on, we take those old batteries and then take out this and take out the material. When I say recycling, it can be anything. For example, I can take the cobalt oxide in that, or I can take the graphite in that and try to upcycle it also. Recycling is the reuse it, or upcycling means like I can just use it, take it out, and then use it for some other forms of batteries, or take out the lithium from that, store it and use it. All these are being done, but it's a tricky thing to do it. It's not that cost effective as well. But then, we don't worry about cost in that factor when it comes to these kind of issues. So there are multiple ways of doing that. There are chemical treatment which needs to be done initially, and convert this, and then, retrieve the lithium, retrieve other elements. I tell you, it's not lithium. Even cobalt is a very, very critical element these days. More than lithium, cobalt is a rare element. So all these cobalt oxide, we take out the cobalt and then, use it, reuse it. So there's a lot of work going on recycling the lithium-ion battery. Thanks for asking that
Then
question.
Deepthi TS, you raise your hand. Deepthi. And Prajesh. Adil.
Hello, sir.
Adil asked directly. Okay, Adil.
So my question is, can we make electricity by the help of Earth's magnetic field?
Electricity by Earth magnetic field, there's a different thing. You can magnetic storage, people are talking about it, right? Not in the base of batteries that I know of, right? There are other ways of, storing, in terms of the material, data storage, and all people talk about it. Not in the case of energy storage as such, I would say.
Okay.
Yeah, there's another hand came.
Okay, Deepthi.
Yeah.
Okay.
People
Gautam, do you want to ask? Okay.
Yes, sir.
Okay.
Sir, I'm Gautam. I'm from Kannur. So I completed my 10th. So my question is, what are the materials we're going to use in the case of flexible batteries?
Oh, okay, good. Yeah. Okay, so flexible battery has not come to, it is not being commercialized yet. It is not into that scale. But then what is being used is like something called carbon nanotubes, right? Because in order to have the flexibility, you have to worry about this thing. It has to be, rather it could be easily formed into a flexible film, like a, bed sheet or something. So we make, you can use carbon nanotubes. These are like, cylinders made of carbon. And these cylinders, the size is of the order of nanometer, I'm saying, right? So these are being used as anodes, but then at the other side, still lithium cobalt oxide used, but then that is used as a thin film on these ones. And that's why the flexibility is maintained there, in that case.
So if we place this
other materials like, sorry?
If you place these batteries in the external parts like the outside or something, so will it be a potential risk for the batteries to get a flame or something?
No, Gautam, understand this. This is what I'm saying is these materials are there. These are, let's say I have 3 layers, like, there's an anode layer, cathode layer, in between there is an electrolyte or insulating layer. Now what I'm saying is this entire layer, instead of particles I'm using which is not flexible, I can actually think about making a carbon nanotube based anode which is flexible, and then another layer which is flexible. And when I make a battery, of course there is going to be a sealing. It can be made of some polymer membrane or some sealing has to be done, and this sealing is certainly there. So it is basically completely sealed. Otherwise you cannot use as a battery, you cannot expose it, right? But the sealing also, the cover of the battery also, we choose a material which is sort of moldable, and that's why it can basically be folded.
Okay, sir. Thank you.
Okay, Surijit, time is reaching, and Surijit, you can ask me your question. Surijit.
Good evening, sir.
Good evening.
My name is Surijit. I just completed 10. I'm from Palkat.
Okay, Surijit, good.
So I basically have written more than 3 questions, but for the consideration of time, I am trying to ask 3, which I think are the most important considering the ones I have written. So the first question is, if the actual voltage of the battery, which you are shown in the earlier slide, is the difference between the 2 peak voltages from anode and cathode, how are the peak voltages are measured?
Okay, there is no peak voltage. There is no peak voltage, Surijit, because sorry, I don't have a code or something. But then it's a plateau. Okay. It's like a plateau, right? So there is a reaction happening and then it goes like this. It's a plateau, right? And, if you were to look at it. So what I'm saying is this reaction happens along this particular voltage. There's a voltage here. And this reaction happens at this particular. Any difference between these two is your, voltage. Peak voltage, I'm not understanding what is the peak voltage you're talking about. When you, and these are higher things, probably, I don't know, you understand this. There's something called cyclic voltammograms where you can actually do this. There's a peak coming here, which is this indicative of the reaction happening at this particular voltage. Okay. So I don't know exactly what you meant by the peak voltage, but then just to tell you, this is the reaction I'm talking about. One reaction happens at the cathode, one reaction happens at the anode, and the difference between these 2 voltages you have them. And if you ask me, how do I increase my voltage of the battery? Simple thing, common sense. What you do, can you bring down this voltage little down, reaction happening at this end little down, and the reaction happening at this little up? Very good. Instead of 3 volt, you can get 4.5 volt. What is the problem? Why are not we going into it? Remember, I mentioned some yellow lines here and here, right? I cannot go further down. If I go further down, it's an unsafe region because there is a potential risk of lithium getting plated as metal. We call it, under plating, we call it. It is dangerous. If I go much higher also, it is unsafe for various reasons.
Okay, sir. My next question was, what is the obstacle in creating an EV battery with both power and energy? Earlier you said that we can only, currently we only have any upper hand in any one of the things. What is the current most recent obstacle in the most modern technology EV battery?
Yeah. See, that's the problem with batteries as such, not electric vehicles. Battery has a problem because anywhere this chemical reactions occur, it's a problem. Because chemical reactions happening means there is some sort of issues because it's not that straightforward thing, right? There will be lag, there will be all sort of sluggishness, everything is there. Then the power is always low. Why is a capacitor having huge power? Ask that question. Because capacitor, the charge is stored at the surface of the metal, surface of the plate. And when the charge is stored at the surface, it is so easy to remove the discharge, because it's just absorbed on the surface. Whereas in the case of battery, these charge carriers like lithium ion goes inside the material and it sits inside. And if you want to discharge it, well, it has to really diffuse through the material. It has to come through the material, get out of it and go. And there is a sluggishness here. So intrinsically, batteries suffer from low power. Now we are trying to improve the material's properties such that this power capability is slightly increased.
Okay, thank you, sir. But if I have the opportunity, I would also like to ask 2 more questions. After that, I will be done.
Okay, that is, you can do it later. I think Nandika and 2-3 others are waiting, I think. Nandika?
Yes, sir.
Please ask your question.
Sure, sir. Sir, good evening, sir. My name is Nandika. I am studying 8th standard. So my question is, if we have the idea of batteries that can recharge with motion, അപ്പോൾ നമുക്ക് ഓരോ റീചാർജ് സ്റ്റേഷൻ നോക്കണ്ടല്ലോ. അപ്പം അങ്ങനെ ഒരു ഐഡിയ ഉണ്ടെങ്കിൽ ആ പ്രോസസ് എങ്ങനെയായിരിക്കും നടക്കുക?
Recharge with what did you say? Sorry?
മോഷൻ വെച്ചിട്ട് നമ്മൾ പോകുന്ന അനുസരിച്ച് അങ്ങനെ റീചാർജ് ചെയ്യാൻ പറ്റും.
അങ്ങനെ ചെയ്യുന്നുണ്ട് because that's what we call retraction. മറ്റേ ഇതിലുണ്ട്. For example, I don't know if you heard about some sort of hybrid vehicles. നമ്മൾ ബ്രേക്ക് ചെയ്യുമ്പോൾ അതല്ലെങ്കിൽ നമ്മൾ പിന്നെ ബ്രേക്ക് ചെയ്യുമ്പോഴൊക്കെ we can basically store. പക്ഷെ അതിനൊന്നും you don't get that much of energy out there. മനസ്സിലായില്ലേ? It's very difficult to get that much of energy to basically fully charge it. ചെറിയ ഇതിന് ഇപ്പോഴത്തെ recent hybrid vehicles എന്നൊക്കെ പറഞ്ഞു വരുന്നുണ്ട്. Basically that's what they use it, right? But as such that much energy is not being produced there, I would say.
Okay sir, thank you.
Adil Prajesh, you have been asked. Please come on. Varu.
സാർ എനിക്ക് സംശയം ഉണ്ടായിരുന്നു, ഒരു സംശയം കൂടി ഉണ്ടായിരുന്നു. അതായത് ഇപ്പൊ ഞാൻ ഒരേ സമയം ഫോണ് കുത്തിയിടുക, അതായത് ചാർജ് ചെയ്യുക, അതിന്റെ കൂടെ തന്നെ ഫോൺ നോക്കിയാല് ചിലവർ പറയും ഫോൺ പൊട്ടിത്തെറിക്കുന്നു. അതിനെന്താ അഭിപ്രായം?
അങ്ങനെ ചെയ്യാൻ പാടില്ല കേട്ടോ.
അതല്ല, ചിലവർ ഈ ലാപ്ടോപ്പിൽ അങ്ങനെ ചെയ്യുന്ന കാണലുണ്ട്. ഒരേ സമയം കുത്തി വെച്ചിട്ട്, അതായത് ഒരേ സമയം കുത്തി വെച്ചിട്ട് അത് ഉപയോഗിക്കുന്നത് കുറച്ചു നേരത്തേക്ക്.
അതും ഡിഫറൻസ് എന്താണ് മറ്റേ ഇതിൽ കുത്തിവെച്ചാലും പ്രശ്നം അല്ലേ? എന്താ കാരണം എന്ന് പറഞ്ഞാല് പിന്നെ നമ്മള് ഫോണിന്റെ പ്രശ്നം എന്ന് പറഞ്ഞാൽ നമ്മൾ ഫോൺ വൈകുന്നേരം രാത്രി കിടക്കുമ്പോൾ ഓണാക്കിയിട്ട് രാവിലെ ഓഫ് ആക്കുള്ളൂ അല്ലേ? ബേസിക്കലി 2 മണിക്കൂർ കൊണ്ട് ചാർജ് ആവുന്ന ഫോൺ നമ്മൾ 8 മണിക്കൂർ ചാർജ് ചെയ്യാൻ വെക്കും. അപ്പൊ എന്താ സംഭവിക്കുക? നമ്മൾ പറയാം ഓവർ ചാർജിങ് ആയി. ഈ ഓവർ ചാർജിങ് ആകുമ്പോൾ എന്താ സംഭവിക്കുക? അത് ഓവർ ചാർജിങ് ആയി അതിന്റെ അത് ഹീറ്റഡ് ആവുമ്പോൾ ഓവർ ചാർജിങ്, അതാണ് ഞാൻ പറഞ്ഞിരിക്കുന്നത്. പിന്നെ ഗോ ബാക്ക് ടു ദിസ്. ഇതിങ്ങനെ നമ്മൾ ചാർജ് ചെയ്യാണ് കേട്ടോ. ഇതാണ് നിങ്ങൾ ചെയ്യുന്നത്. ചാർജ് ചെയ്യുമ്പോൾ ഇങ്ങനെ പോവുകയാണ്. ഇതിങ്ങനെ ചാർജ് ചെയ്ത് അധികം പോയി കഴിഞ്ഞാൽ എന്താ സംഭവിക്കുക പറഞ്ഞാൽ ഈ ഒരു വോൾട്ടേജ് റീജിയൻ മുകളിൽ കയറും. ഈ വോൾട്ടേജ് റീജിയൻ മുകളിൽ കയറുമ്പോഴേ ഇതിനകത്തൊരു ഇലക്ട്രോലൈറ്റ് ഉണ്ട്. ആ ഇലക്ട്രോലൈറ്റ് ഡീകമ്പോസ് ചെയ്യും. കാര്യം അതിന്റെ വോൾട്ടേജിന് അതിന്റെ ഒരു എന്താ പറയാ, അത് ബ്രേക്ക് ആവുന്ന ഒരു വോൾട്ടേജ് അതിന് മുകളിൽ പോകുമ്പോൾ ആ ഇലക്ട്രോലൈറ്റ് ബ്രേക്ക് ആയിട്ട് അതിൽ ഗ്യാസ് റിലീസ് ആവും, ഓക്സിജൻ മറ്റ് ഗ്യാസ് റിലീസ് ആവും. ആ ഗ്യാസ് റിലീസ് ആകുമ്പോൾ എന്താ സംഭവിക്കും? അതുകൊണ്ടാണ് നമ്മൾ ചിലപ്പോൾ നമ്മൾ ബാറ്ററി നല്ല പരന്ന ബാറ്ററി നല്ല ഉരുണ്ടിരിക്കുന്നതാണോ, ചിലപ്പോൾ ബൾജ് ചെയ്തിരിക്കുന്നതാണോ, റൈറ്റ്? ബിക്കോസ് ഓഫ് ദിസ് ഗ്യാസ് ലീക്കേജ്. സോ ഇതൊക്കെയാണ് ഇഷ്യൂസ്. അപ്പോ ഫോൺ നമ്മൾ യൂസ് ചെയ്യുമ്പോൾ എന്ന് പറഞ്ഞാൽ ഇത് എന്തെങ്കിലും ഇതുപോലെ സ്പാർക്ക് എന്തെങ്കിലും ചെയ്തിട്ടുണ്ടെങ്കിൽ ദെൻ അപ്പൊ തന്നെ it gets burnt, right? That's what you should not use it, right? പക്ഷെ നേരെ മറിച്ച് ഇത് നമ്മൾ അങ്ങനെയല്ല. ലാപ്ടോപ്പ് of course it is also there, that it has all the other electronics also taken care of in much cases, and then you don't really excessively plug in. That's another reason I would say.
ഹലോ സാറേ, ഞാൻ നേരത്തെ ചോദിച്ചിരുന്നല്ലോ സംശയം. അതായത്
എന്താണത്?
അതായത് ഇപ്പൊ ഇലക്ട്രിസിറ്റി ഉണ്ടാക്കാനായിട്ട് പല ഐഡിയാസ് ഉണ്ട്. അതായത് ഈ ഹീറ്റ് വെച്ചിട്ടുണ്ട്, പിന്നെ വാട്ടർ ഹൈഡ്രോ ഇലക്ട്രിക് ഉണ്ട്, സോളാർ പാനൽ, വിൻഡ്, അങ്ങനെ പലതും ഉണ്ടല്ലോ. അപ്പോ ഈ എർത്തിന്റെ മാഗ്നറ്റിക് ഫീൽഡ് വെച്ചിട്ട് നമുക്ക് എന്തെങ്കിലും ചെയ്യാൻ പറ്റുമോ ഇലക്ട്രിസിറ്റി ഉണ്ടാക്കാനായിട്ട്?
മാഗ്നറ്റിക് ഫീൽഡ് ഇൻഡയറക്ട്ലി ചെയ്യാൻ പറ്റുമോ? ഐ ഹാവ് നോട്ട് ഗോൺ ടു ഇറ്റ്. ഞാൻ ഉനക്ക് നോക്കിയിട്ട് പറയാം. പിന്നെ പ്രജീഷേ കേട്ടോ, എന്റെ ഒരു ഇമെയിൽ എന്തെങ്കിലും അയച്ചിട്ടുണ്ടെങ്കിൽ ഐ ക്യാൻ റിയലി ലുക്ക് ഇറ്റ്. ഞാൻ ബാറ്ററീസ് ആയിട്ട് കണക്റ്റഡ് ആയിട്ടൊന്നും ഇല്ല. But there will be other indirect ways of doing it. Certainly, നമ്മൾ പഠിക്കുന്ന basic physics which is certainly there are a lot of things one could do that.
സാധ്യത പറയാൻ പറ്റുമോ? അത് സാധ്യത ഉണ്ടോ?
എനിക്ക് I don't want to clearly give an answer. നോക്കിയിട്ട് പറയാം. കേട്ടോ. റീസെന്റ് ട്രെൻഡ്സ് എന്തെങ്കിലും ഉണ്ടെങ്കിൽ ഞാൻ നോക്കിയിട്ട് പറയാം തീർച്ചയായിട്ടും.
Mone, we'll get it, Mone. Okay, you raise an email to me or
I will come back to you. I'll come back.
Okay, Mone.
Thank you, sir.
Okay, thank you, sir. I think a lot of questions are there, but we have to finish now, and we have to get a feedback and thanks, vote of thanks from Archit. Archit, are you there? Archit?
Yes, I'm there.
Okay. It's your turn to say vote of thanks to our guest, Dr. Shaijumon. He delivered a talk and he connected to you the IISER. IISER is the research institute in Kerala. It's a premier. Only 7 IISERs are there. One among them is Kerala, and it may be your people's destination in future also for your study for BSMS or any research like that. And Archit, it's your turn to make a vote of thanks. Vote of thanks. Okay, Archit.
Yeah.
Yes.
Yes, I understood many things about batteries. I wasn't clear about batteries on many things like anode, cathode, but in this class I understood many things about batteries. So thank you very much about that.
Okay. Okay, thank you, sir.
Thank you, thank you all.
And we express our sincere gratitude on behalf of UL Club for you connecting with us, and we request your support for this program, connecting much more scientists and professors to interact with our students. It's happening in every second Saturday. It's continuing here, sir.
Yeah.
Sir, Kuti sir, please.
Sure. Thank you so much. Thank you so much. It's a pleasure, and I really enjoyed.
Okay.
And so nice to talk and interact with kids. I would love to come over to your place sometime, and then attending schools and also at some point of time. Okay. Thank you so much. Yeah.
Okay. Thank you.
Bye bye.
Thank you very much. Bye. Kuti sir, you are muted. Okay. Thank you. Kuti sir, muted. You are muted, sir. Muted. Please.
Okay. Sorry. It's an excellent talk and an excellent afternoon for our students. How do you feel, Nandika?